we see in a presentation. Okay. Motion of the particle is somewhat like this. We say this side displacement is Sx, this is what? Sy. Okay. Any point of time, if you say ds, right? ds will have two components, dx and dy, which are independent of each other. Okay. If you talk any velocity v, okay, this v will have vx and vy. Okay. Okay, which can be solved separately. The 2D motion can be break down in 1D in x direction and 1D in y direction. Here you will have independent variables, Sx this side, Sy. Both are independent of each other. Okay. Just the common thing is time, right? If any point of time this particle is reaching this side, right? So there is a displacement in x, displacement in x, displacement in y, right? But the time is same. The equation of motion you will apply this side and this side. Time you will keep same. I will tell you how. As displacement and vx velocity, acceleration ax. Okay. Same ax equation is what? dvx by dt or vx into dvx by dx. Okay. And what else? That's it. Or vx is equals to dx by dt. His own, this own thing. Okay. Here what? Vy, ay, and ay is equals to dvy by dt is equals to vy into dvy by dy. And velocity in y direction is what? dy by dt. Okay. I'm not talking about y direction. Y direction variable, constant, zero, doesn't matter. Okay. If it is constant in x direction, you can apply the equation of motion in x direction. That's it. Okay. How you will apply? Vx is equals to ux plus ax into t. And what else? Sx is equals to ux into t plus half ax into t square. Vx square is equal to ux square plus 2ax into sx. Okay. Y direction 0, variable, constant, doesn't matter. Okay. This x is independent of y. Okay. And similar things in y also, right? Y also same things. Okay. Understood? Equation of motion are valid if acceleration is constant. If acceleration is constant. Okay. In y, that one. In x, this one. Yes, ma'am. Write down the point. Velocity at any time. So what you will do is, you will solve in x and y direction independently. Okay. And let's say in x direction there is a displacement given, some time is given, and initial velocity given. You can find out the final velocity, okay, by whatever means. Okay. You got the final velocity in y. By some method you got the final velocity in x. Okay. He will ask you the net velocity. So what will be the net velocity? Vx I cap plus Vy j cap. That's it. Understood? Similarly, acceleration at any time. Write down this thing. T. Acceleration is what? Ax I cap plus Ay j cap. Similarly, displacement at any time T. What is that? Write a note. Write a note. Write down. We can break motion in plane. We can break motion in plane. We can break motion in plane into two rectilinear motion. Into 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 TWO. 2. Into two rectilinear motion. Keeping KWPING. Keeping 90-degree angle between two directions. Keeping 90-degree angle between two directions. Full stop. Next point, right there. Variables along one direction. Variables along one direction. Variables along one direction. Bracket x-axis. Variables along one direction. Bracket x-axis. Bracket close. Does not affect or doesn't affect variables along, doesn't affect variables along other direction. Variables along other direction. Bracket write down y-axis. Understood? If you divide any particular motion into motions, okay, two directions which are perpendicular to each other, they will not affect each other. Okay, simple logic is there. Question, write down. Start with all questions, write down first. Question number 1. Particle started from origin. Write down. Particle started from origin with v vector equal to 3 I cap and a vector equal to 3 I cap plus 4 j cap. Then find a part v at t equal to 2 seconds, b part speed at t equal to 2 seconds, c part position of particle at any time. Question number 2. Noted this thing? Solve in x separately, y separately. Okay. Initial velocity given 3 I cap means in y direction what is the velocity? 0. Right. Acceleration given in x direction 3, y direction 4. Okay. So in x direction what we see? Initial velocity 3, acceleration 3 and velocity at t equal to 2 he asked, right? So x direction you solve velocity, in y direction you solve velocity. V vector equal to vx I cap plus vy j cap. Okay. Let it. Second question, write down. A particle started from rest. A particle started from rest with acceleration a vector equal to I cap plus 2 j cap. With acceleration a vector equal to I cap plus 2 j cap. Full stop. If initial position of particle is 2, 3. If initial position of particle is 2, 3, then find position after 4 seconds. Then find position after 4 seconds. Then question number 3. A particle located at 2, 4 is moving with velocity u vector equals to 2 I cap plus 3 j cap at t equal to 0. Full stop. If acceleration of particle A vector is equals to minus 2 I cap plus j cap. If acceleration of particle A vector equal to minus 2 I cap plus j cap, then find position at t equal to 3 seconds. Then find position at t equal to 3 seconds. Okay. Next, question number 4. The particle is started from origin. With initial velocity u vector equal to 4 I cap. With initial velocity u vector equal to 4 I cap. And acceleration 3 I cap plus 4 t j cap. Variable acceleration 3 I cap plus 4 t j cap. Here bracket write down t is time. Okay. Then find A part. Then find velocity at t equal to 2 seconds. B part, position of particle at t equal to 2 seconds. Then fourth. Done everyone? Five. If coordinate of particle changes with time as as. If coordinate of particle changes with time as given here what? X equal to 4t square and y is equals to 2t cube. Then find A part, velocity at t equal to 2 seconds. As I said, solve in the x and y independent. Okay. Question number 6. Fifth noted. Acceleration at t equal to 1 second. Okay, done. Question number 6. If position of particle is given by, if position of particle is given by r vector 2t square I cap plus 3t j cap. If position of particle is given by this, then find a part velocity at t equal to 1 second, b part acceleration at t equal to 2 seconds. These are the questions. Start solving. Okay, we have 20 minutes. Tomorrow we will start projectile. Little bit questions we will solve today only. Okay, so we will start with our first question. I'm giving 5 minutes. Try to solve. 5 minutes is very much. Still solve whatever. Solve it. 4. Agree? These are the values given. He asked velocity at t equal to 2 seconds. So you solve for Vx and solve for Vy separately. Okay. V is equals to u plus at. So Vx equals to a part I'm solving. A part na? So Vx will be what? 3 plus, you can say ux plus ax into t. Vx will be how much? 3 plus 3 into 2 seconds or what? 2. So this is how much? 9. And here Vy, if we solve, how much is that? 0 plus 4 into 2. How much? 8. So velocity, what can I say? 9 I cap plus 8 j cap. If he asks me magnitude, I can calculate the magnitude from here. Okay? Understood? He can ask you angle with the horizontal of the velocity. That also you can answer from here. Right? Anything you can ask. B part. Speed at t equal to 2 seconds. Speed means what? Magnitude? How much? Under root of 81 plus 64. How much? 140. 140? It's whatever, 140, 145. That's it. C part. What is saying? Position of particle at any point of time, right? In this given things, okay, how can I find out the particle position? If t is given, let's say t is t only, right? Then what will the position? S equals to ut plus half a t square. Acceleration constant, na? So I can apply that equation. Okay. So what we can say here, Sx value ut 3t plus half acceleration 3 into t square, right? What is the Sx value? 3t plus 3 by 2 t square. Okay. Sy value ut 0 plus half acceleration 2 or how much? 4. Sorry. 4 into t square. So Sy is how much? 2t square. Okay. He didn't ask me the displacement. He asked me the coordinates. Right? The initial position is what? Origin. Origin means 0, 0. From 0, 0, there is this much displacement. Okay. Means it will be positive or negative depending upon that. And in y direction, this is the displacement. Right? So what you will write down? Coordinate 0 plus Sx, 0 plus Sy. This is the final coordinate. Got it? If this value is coming positive, means move that side. If it is coming negative, it move that side. Automatically it will adjust. Okay. This is the coordinate. Okay. So at any point, at any time. Okay. Got the point? He asked the coordinate or displacement, position of the particle. You can ask the coordinate also in terms of, if we say S vector. S vector is what? Sx I cap plus Sy j cap. Right? Next question. Ax 1 and Ay 2. Agree? initial position of the particle means coordinate is given 2, 3. Then find the position after 4 seconds. Okay. Initial velocities are given. Ux how much? 0 and Uy is how much? 0. So here Sx, what you will write down? Ut plus half a t square. So half a 1 into t square, that is 2 square. Okay. And Sy is how much? Ut plus half acceleration 2 into t square, that is 2 square. How much is this? 2. And how much is this? 4. Okay. Displacement in x direction is 2 and displacement in y direction is 4. So how much is this? 8. And how much is this? 16. So initial coordinate is what? Initial position. How much? 2, 4, 3. 2, 3. Okay. And then in x direction plus 8 displacement. Means what? 2 initially he was and then 8 more displacement. What is coordinate? 10. So I can say final position. Position will be what? 2 plus Sx and this side 3 plus Sy. Okay. Whatever positive or negative it is coming, accordingly you have to put. Okay. It will adjust. So what is this coming? 10, 16 plus 19. 10, 19 is the final coordinate, final position of the particle after 4 seconds. Okay. Next question. Particle located at 2, 4. Moving with velocity. Initial velocity is given what? 2i cap plus 3j cap at t equal to 0. If acceleration of the particle is what? Minus 2i cap plus j cap. Find position at t equal to 3 seconds. Okay. T equal to 3 seconds. Easy question? Easy or not? The same as previous, just one more thing, increase initial velocity, right? So Sx, if we solve, then what is ut? Ut is what? 2 into 3 plus half into acceleration minus 2 into 3 square. Correct? What is this? How much this came? 6 minus 9. 6 minus 9 minus 3. Okay. Similarly here, Sy, ut, that is 3 into 3 plus half into acceleration 1 into 3 square. How much is this? Okay. So final position. I can say 2 minus 3, 4 plus 27 by 2. Okay. Plus minus 3. Okay. Got it? This is your answer. This is done. Next question. A particle started from origin with initial velocity 4i cap. Agree? This is only question, na? Started from origin means initial coordinate 0, 0. Initial velocity 4i cap. Acceleration 3i cap plus 4t cap means variable acceleration. Find velocity at t equal to 2 seconds. Okay. Velocity we have to find out. So x direction acceleration is constant, right? No problem. So we can solve. First of all, write down like this. Ux is what? 4. Ax is what? 3. And Uy is what? 0. Ay is what? 4t. Variable acceleration. Okay. This side, final velocity at t equal to 3 is asking. Then after something else also is asking. Position of particle at t equal to 2. Everything at t equal to 2 only, right? So A part. First of all, velocity v equals to u plus at. So 4 plus acceleration 3 into 2. How much? Vx. How much? 10 meter per second. Here, if you solve an x variable, right? So we can't apply equation of motion. So we will do, what is this value? dvy by dt is equals to 4t. You can solve dv by dt. Don't confuse yourself with y and x, those things. Okay, you can solve dv by dt, simple. Okay, so here dv equals to 4t dt. Integrate when time is 0, velocity is 0, initial velocity is 0, right? When time is t, velocity is v. Why I am not putting 2? Because I have to get for position also. So again I have to integrate, right? That's why. So v equals to 2t square. Okay, right? From here you can put the value t equal to 2 and you can get the velocity, but I need the position also. So for that, v is equals to ds by dt or dy by dt. dy by dt equals to 2t square. So dy is equals to 2t square dt. Integrate from where to where? T equal to 0. What is the position? Coordinate 0. Na? Started from origin, as he is saying. T equal to t, let's say y. So y is equals to 2t cube by 3. Okay. So here at t equal to 2, y is how much? 8. And at t equal to 2, what is y? 16 by 3, right? Okay. So final velocity I can say at t equal to 2, velocity will be 10 i cap plus 8 j cap, and position will be here we didn't solve the sx is what? Ut, 4 into 2 plus half acceleration 3 into 2 square. Agree? How much is this? 6 plus 8, 14. So this is 14 comma 16 by 3. This is the coordinate, this is the velocity. Okay, that's it. 14 comma 16 by 3. Next, if coordinate of the particle changes with the time, x is given as 4t square and y is given as 2t cube, then find velocity at t equal to 2 and acceleration at t equal to 1. Okay, we have to assume that initial velocity is 0. Okay, otherwise you will not able to solve. Okay, so position is given. Sorry, no need to do that. From here we can say vx is what? Differentiation of this, right? Differentiate this, what you got? 8t. Acceleration 8. Okay, vy how much? 60. And ay how much? 60 square, na, this is right. So what will come? 12t. Okay, at what time he asked? Velocity at t equal to 2. At t equal to 2, velocity vector will be what? 8 into 2 I cap plus 6 into 2 square j cap. Agree? And at t equal to 1, he asked what? Acceleration. Agree? This one, no? So what is that? A vector, I can say 8 I cap plus 12 into 1 j cap. This is the acceleration. Okay. Position is given, so we can solve for velocity and acceleration. Solve x separately, y separately. Okay. Next is what? R vector is given. R vector is what? Position vector only. So from there we can say x is what? 2t square and y is what? 3t. So velocity vx is what? 4t and vy is what? 3. Here ax is what? 4 and ay is what? 0. So velocity at what? T equal to 1. V vector at t equal to 1. How much? 4 I cap plus 3 j cap. Acceleration at whatever point he is asking, doesn't matter. It will be how much? 4 I cap. Okay. Here you can put unit also, meter per second and meter per second square, like this. Okay. You'll just understand. Projectile we are studying here ground to ground first of all. So if we say a particle is there, okay, and this particle is, see if it is projected upward, downward, those things we seen already, right? Okay, So if it is projected along the acceleration or opposite to acceleration, exactly opposite or exactly along that acceleration, then it's a rectilinear motion. Okay, understood? That's a rectilinear motion that we have completely studied. If you project the particle, not gravity is downward, right? Not this side or not this side, okay, at some oblique angle, oblique incident, okay, then it's a projectile motion. So you project it with the initial speed u, at initial speed u, at an angle theta with horizontal. Okay, so this particle goes something like this. Okay, now we have to study some things here. Okay, first of all, that at any point of time gravity is downward, acceleration downward. So if I divide his motion in two parts, horizontal and vertical, okay, I can say his horizontal velocity, initial velocity is what? U cos theta, right? And vertical velocity is u sin theta. These are the initial velocities given. Ax acceleration is what? 0. And ay acceleration minus, right? These are the acceleration. So I can say horizontal direction there is no acceleration, so horizontal velocity constant, right? There is no acceleration, then constant. So at this point also I can say same u cos theta will be there. At the maximum height point also it will be u cos theta. This point also it will be u cos theta. And when it will hit, just about to hit, that time also this side u cos theta. No problem. In the y direction, here as is, like we say this particular projectile is combination of two projectiles, combination of two motions. A particle projected this side with u sin theta speed, it will go up and come down, okay, plus a particle projected this side with u cos theta going with constant velocity, okay. So this particular projectile is combination of these two, okay. So in this direction, y direction, what will happen? Gravity downward, so this u sin theta will decrease slowly. Here some less value will be there, Vy, okay. And at the maximum height, what happens? Vertical component will get 0. Why vertical component 0? If non-zero, then means he is going still up, right? So let him go up. That is the maximum point. So at this point, Vy will be 0. Okay. We say how much time it is taking from here when you projected till he landed. That is known as time of flight. Okay. And how much maximum height he is reaching, that is known as h max, we call it height maximum height. And horizontally, how much distance he covers in x direction, that is known as range. Okay. Now before we solve, some more observation if you do. Here now solving for time of flight, okay. Solving for time, how much time it will take, right? Now if there are two directions, vertical and horizontal, which direction should I solve? That is a question, right? Okay. So if I talk that the particle will have only horizontal velocity u cos theta, okay. U cos theta have continuously going, there is no acceleration, going, where it will stop? Not decided, right? It's going with constant velocity. Will he decide when the particle will hit the ground? No, because this is going with constant velocity this side. This velocity is not deciding when he will hit the ground. When it is hitting the ground, that point of time motion is ended, right? But this horizontal velocity is not deciding when he will hit the ground, right? But if I talk about u sin theta will say I am going to height, and when my height will become again 0, that is the point when motion ended, right? So this vertical direction is deciding when the motion is ending, okay. So that's why you always calculate time of flight in vertical direction, or you call it direction perpendicular to the plane of surface, okay. Inclined plane will come, that time it will be different, right? So always perpendicular to this plane, because the velocity which is along the plane is not deciding when he is hitting the ground, okay. That is only giving him range, okay. So what we are saying is vertical direction velocity is deciding when he will hit the ground, okay. So think just only in vertical for the time of flight. Okay. Here to here, particle projected upward with, as we said, horizontal and vertical will not have any relation, no disturbance. So horizontal you solve separately, vertical you solve separately. Okay. So in vertical, initial velocity u sin theta, gravity downward minus u. So here to here, how much time it will take? We can say which equation of motion you go to u sin theta by, I also know formula more than I know. Okay, so wait, but equation of motion we have to solve. In vertical direction, I can say what is the displacement between this point and this point? 0. Same level it is coming, right? And initial velocity you know, and you know the gravity. Acceleration, which equation? Ut plus half at square, right? So displacement how much? 0 is equals to ut, u sin theta into t plus half into minus g into t square. So t is what? 2 u sin theta by g. You see here that u is replaced with u sin theta. That's it. Okay. Instead of seeing in this diagram, you start seeing in this diagram. Okay. Because time of flight I am solving in vertical direction, you see only the vertical direction displacement, right? Particle is going like this. But if I see only the vertical coordinates, right? Vertical direction. Here is the particle at certain level. Again, he is at the same level. So displacement in vertical direction, 0. Got the point? Okay. And the vertical direction initial velocity, u sin theta. Vertical direction gravity given. So I will solve for time here total. Understood? Start seeing in this diagram. Okay. Vertical direction displacement, 0. Understood? So time of flight came what? 2u sin theta by g. 2u by g was when the particle was thrown up. U is replaced with u sin theta. Okay. Because now instead of u, it is u sin theta. Next is what? Maximum height. Okay. So maximum height, again same thing. Which point you will apply equation of motion? This point and this point. Obviously, if you are solving in h max is what? Displacement in y direction. So you will solve in y direction. Okay. So in this direction you want the displacement. You want the displacement, but what you know? Initial velocity you know. Final velocity you know. At h max, what will the final velocity? 0. In vertical I am talking. Horizontally there is u cos theta. Vertical what? 0. Initial velocity, final velocity and gravity. Acceleration you know. Which equation? Third equation we can use. So we can say v square, that is 0 square is equals to u, that is u sin theta whole square by plus 2 acceleration minus g. Downward na? So all upward vectors are taken as positive, all downward are negative. Into displacement. This displacement is coming positive and it should come positive because displacement is overall upward, right? So positive. So watch, h max is how much? U sin theta whole square by 2g. U sin theta, u was replaced with u sin theta now. Earlier it was u square by 2g. Okay. Formulas, if you are not able to remember, it's okay completely. You should know what in between what 2 points you should apply equation of motion, and in between those 2 points, do you know sufficient number of variables or not? Out of 5, how much you know? Okay, that's it. Next is what? Range. Now think about the range. Range is what? Horizontal displacement, right? Horizontally what we know? Acceleration is 0, basically. Initial velocity I know, that's it. Okay. Do we know time? Yes. Time of flight is only the time. For how much time the particle is in the air. In that much time, how much horizontally he covered the distance. That is only the range, right? So time you know, velocity you know, and here there is no acceleration. So s equals to ut plus half a t square you call it, or s equals to u into t. Simple, if velocity constant, right? So range is nothing but what? Horizontal velocity u cos theta into time of flight. Okay. So there you solve, then you get u cos theta into time is 2u sin theta by g. So from here u into u square, 2 sin theta cos theta is sin 2 theta by g. Okay. Sometime if I talk about good questions, okay, what will happen is, instead of like this, he will say 2 into uy by g. Okay. If he only wants you to calculate the time of flight, he will not give you the UX. Okay. He will only give you sufficient information that you can calculate the UI. Okay. That's it. Because for time of flight, you don't need the UX. You don't need the U. You don't need the theta. You need the UI. So you calculate that thing. Okay. Okay, because we have to solve for time of flight in vertical direction, so we need only vertical variable. If you talk about Hmax, this can be also written as uy square by 2g. Okay. Here this thing, one thing is like this. It can be written as ux into time of flight. Okay. Other thing here also I can see u cos theta is what? Ux, and u sin theta is what? Uy. So this can be also written as 2 ux uy by g. Okay, basically ux into time of flight, which was 2 uy by g. Okay, sometimes he will not give you the sufficient number of variables, but don't panic, just think how we can rearrange the things. Okay, understood? So like that these things are. Okay, what do you think to note down? But wait, one more thing. At this point of time when he is hitting the ground, horizontal velocity u cos theta. If I ask this velocity, how much it will be? U sin theta. How? Between this point and this point, vertical direction I am solving, right? Vertical direction I want the final velocity. So between this point and this point in vertical direction, what I know? Displacement 0, gravity downward. So v square equal to u square plus 2as you apply. Okay. V equals to plus minus u. Agree? So if this is u sin theta upward, if a particle I throw up, it will come with the same velocity in my hand because displacement is 0. So downward u sin theta. Okay. The net velocity will be this side v, u only, right? With horizontal angle theta. It will hit the ground with the same angle as you projected it. Okay. Next, any Vy at any point of time. At any point of time, he can ask you the velocity also. At any time t, if he asks you the velocity, at any time t, velocity if he asks, v will be what? If I talk about v vector, basically in horizontal constant, horizontal same na. Net velocity, how you are writing in previous 6 questions, where you are writing that same way. Initial velocity same in this side, right? There is no acceleration, I cap. In y direction, there is initial velocity, there is acceleration downward, and time is given, let's say t. So what is the velocity? V equals to u plus at. So u sin theta minus gt, jk. This is the velocity. Can ask you position vector also. Okay. Position vector will be what? At any point of time. U cos theta into t. Horizontal displacement, this only. S equals to ut plus half at square, both directions you apply. Okay. And this side what? This is I cap. U sin theta t minus half g t square jk. Got the point? Any point of time, position vector with respect to the initial point or velocity vector. Okay. Understood? Now here one more thing he can ask you, that here at any point of time you find out the Vy. Okay. What happened to you? Eyes are turning red. Huh? Vampire you will become. So net velocity is what? That same we find out, right? Any point of time. He can ask you here alpha. What is alpha? Can we tell 10 alpha is how much? Agree? Right? Okay. Sometime he will give you the alpha at any point of time, right? Okay. So like this it can be also written. So here what we are saying is net velocity at any point of time, what you will say? Velocity is speed under root of Vx square plus Vy square, right? Vx is constant, Vy is changing. What can be the minimum value of Vy square? 0. That is at topmost point. That's the speed minimum. Got it? Okay. That's what he's saying. Question, write down one. Formula based question I will not give. You have to think between what 2 points you should apply the equation of motion. Projected with initial velocity u, okay, and he is saying that this is A point, this is B point, exactly opposite, same level, and level is what, 25 meter. Okay, write down in this language. A particle is projected as shown. A particle is projected as shown. Full stop. It takes 4 seconds. It takes means one thing, I can apply equation of motion from here to here. That's it. Simple thing. One thing is that only, right? So if I apply, what I will get? There should be something to find out. I know the three things here. Here to here displacement is vertical direction. If I talk 0, time is given 4, and acceleration is -g, right? So let's assume at this point of time, vertical direction velocity is Vy, and here initially is Uy. Okay, correct? So if Vy is the velocity, then can we find out Vy? Between these 2 points, equation of motion if you apply, so what we can say? S equals to displacement 0 ut. What is Vy into t? That is how much? 4. T plus half acceleration minus g into t square. So t is equals to 2 Vy by g. Something like that. Here to here only there is a part which is also a projectile. Okay. In a projectile, when you see, everything is this half and this half is symmetric. Okay. Just the thing is, here it is going up, here it is going down. That's it. Velocities are also exactly opposite, like that. Okay. So here, this we know time is what? 4 seconds equal to 2 into Vy. We want to know g is given. Vy how much? 20 meter per second. Okay. Right? If Vy we know, can we get the Uy? How? In between these 2 points, I know the Vy, final velocity, I know the displacement, and I know the gravity. Right? That's it. So V square, that we know 20 square is equals to Uy square plus 2 acceleration minus g into displacement 25. Okay. So Uy square how much? 20 square how much? 400 plus this is 500. So Uy is how much? 30 meter per second. Okay. Got it. Time of flight formula. 2 Uy by g. That is what? 6 seconds. Right? Maximum height formula. Uy square by 2g. How much? 900 by 20. 900 by 20 how much? 45 meter. 45? That's it. Because he asked me the time of flight and the maximum height only, so we don't need the horizontal things, right? That's all. Only solve in vertical. Because he's talking here also time only, solve in vertical. If he's talking about any 2 points time, then you solve in vertical. Okay? Got it. If he is talking about horizontal displacement, then particularly solve in horizontal. Otherwise, there is no need. Okay? If he have gave me from here to here horizontal displacement, then I have solved in the, I have got u cos theta. Because u cos theta into t is the displacement, right? Like that. Next question, write down. Particle projected with 20 meter per second at an angle of 60 degree. Okay. Write down. Find time after which velocity makes angle 45 degree with horizontal. Find time after which velocity makes angle 45 degree with the horizontal. Root 3. See here. Particle projected, it will go something like this, right? So as he is this side 60 degree, slowly he will turn like this, right? That means what? Well, angle will decrease with the horizontal. So at a certain point of time, his velocity will be such that he will make this side, this angle is 45. Okay. So, and the same point will come here also. It will be like this V and this is 45, right? Okay. But in both the cases, I know one thing, that this horizontal component is what? This is 20, right? So 20 sin 60 is how much? 10 root 3 cos 60 sin 30, 10, right? So this will be 10 here and this will be also here 10. So if this is 10 and this angle is 45, so this is 10, right? You can apply tan theta. Tan theta equal to tan 45 equal to Vy by 10, right? This I told you, na? Tan alpha, like that. So here this 45 angle is given, so 10 and this is also 10, okay? So from here to here you want to time. First of all, this velocity is how much? 10 root 2, root 3 or root 2? Root 3. 10 root 3 sin 60, right? So here to here you want the time. So time will be in vertical direction. At any point of time, if you want the time, it will be in vertical only, okay? So in vertically from here to here, what you know? Initial, final and acceleration. So time you will get V equals to U plus AT. V is what? 10. U is what? 10 root 3 plus minus G into time T1. T1 what? Root 3 minus 1. Okay. For this one, we can say final velocity is minus 10. Okay. You have to put with sign. If you put with sign, you will get correct answer. Final velocity is minus 10 is equals to initial velocity 10 root 3 plus minus G into T2. Okay, gravity downward, so minus G. Okay, sign you remember. T2 came how much? Root 3 plus 1. Got it? Okay, here let's understand ground to ground only. Okay, so if you project at any angle, right, it is a projectile like this. Okay, so if we talk about like different angles, if you do projectile, the projectile will be different, right? Like vertically, when particle is thrown up, it will go exactly same straight line and same straight line come down. Got it? Okay. Okay, so that we can understand with our values. And let's take this value how much? 10 only. And this projectile will be very small. We can zoom in, but still, let's take 20. Okay. So here I am saying different angles, different projectiles, right? Now what I am saying is velocity, speed constant, let's say, okay? And when you do different angles, projectile range will be different, okay? So we are saying at different angles, you are finding out the range, and when you find out, we want the range maximum. So what angle should be the projection, okay? We will find out with the differentiation what angle it will come. 45? At 45 degree, if you do a projectile, this will be the maximum range possible. So where he is hitting? There, okay? If you do this projectile at any angle, any other angle, if less than it, it will be below it, okay, behind it. And if you do more than it, still it will be behind only. Height will be bigger, but range will be less. Getting the point? Understood now? 18, that's why it was 18. That's why it was 18, okay? So we don't need the values, okay? We don't need to verify. This is exactly correct, okay? So 45 degree, maximum range, there it is hitting. And if you below it, it will hit below it. If you hit more, still it will hit minimum, less than that one. So range maximum at a particular velocity will come at 45 degree angle. Okay. Second thing, that if I do a projectile at 30 degree, okay, 30 degree, okay, this last projectile is at 30 degree here, right? At what point he is hitting? Here, right? Okay. Now if I do with 60 degree, it will exactly, the range will be same, exactly same, here only hit, okay, both 30 and 60. Why? Complementary angle, okay, because there you have in the range formula, what you have, 2u square sin theta cos theta. Sin theta is replaced with cos theta and cos theta is replaced with sin theta, okay, understood? Like that it comes. That's why. So if the angles are complementary of each other, okay, one is theta, one is 90 minus theta. Like even if we take 50, like let's say you take 42 complementaries will be what? 48, right? So 42 and 48 will have same range. You see is hitting here. Let's go with the 48. It will come exactly same. See, right? Here. Okay. Exactly same, right? And 45 will be more than both of them. Range will be more than them. Okay, little bit ahead. Got it? This is the way range is calculated. Now here some other projectiles we will also study, like with the height, how much it is. Okay, you can increase the height of projectile. Okay, and then you can do this projectile. Will see what is that? Particle projected horizontally, right? I will not bring you to the simulation again, so you see it now only. Horizontally like this. So in this projectile also, this is a combination of particle in vertical direction. What is the velocity initial? 0, because you are projecting horizontal. Horizontal velocity constant, and particle dropped downward. Downward direction it is like dropped particle, because initial velocity is 0. Okay. So this is one thing, and other thing is at certain angle if you do projectile, then also it will be like this. Okay. That's how it is done. Okay. Many projectiles you can do, and other than that, at low angle also you can do same. It will be it is looking like straight line, but actually it is a projectile only. If you see it from here, it will look like projectile. Straight line it is not there. Okay, got it? That's it. These all are projectiles. That's it. What else? There is nothing else. Okay. Air resistance we will see later on. Air resistance, how? Air resistance, no need. If from here you do projectiles at less angles, it will be like this. If you increase 45 degree like this, if you decrease the angle, it will be like this. If you increase the angle, it will be like this. Okay. At different angles, this will be the different projectiles. Okay, understood? Like this. So we are saying here you are keeping initial velocity constant. Okay, and you are changing just angle, and these are the all projectiles you will have. Okay. Now how to find out that angle for that range is maximum? So first you write down the range. What is range formula? U square sin 2 theta by G. Okay. Or for easier, okay, like this is okay. Okay. Now next what? Range maximum. For theta is variable, so dr by d theta should be 0 for maxima or minimas, right? Right. So find out, differentiate this u square and g constant. So u square by g outside, sine 2 theta derivative is what? Cos 2 theta, and this should be equal to 0. These are not 0. Cos 2 theta 0. So 2 theta equal to 90, theta equal to 45. Here by 2 will also come. Sorry, multiply with 2. Right? Agree na? Sine derivative cos and then 2 theta derivative 2. Okay. Theta equal to 45. Okay, so if you project a particle with a 45-degree angle, its range is maximum. Okay. Got the point? Next one question is that when you see a javelin throw or something like that, okay, in that he don't throw the javelin at a 45 degree. He throws around 36, 38 like that. Okay. Why? Not air resistance. First of all, where he is throwing and where he is standing, those things are not at same level. Not exactly same level. Okay. This is one reason. Because he is doing from some height. Little bit only, floor is there, but still some height is there. Second reason is when you have any javelin kind of thing big, okay, that thing, if I throw at a 45-degree angle and I throw at 30-degree angle, my power, hand power is different, right? I can't throw with same velocity at different angles, right? If I throw something like this javelin I have very rod, will I throw this side and this side with same velocity? No, right? So that depends upon what angle I'm throwing will depend, velocities will change, right? So they choose the best option for that. Velocity is also maximum and range also maximum, and my hand power also delivers maximum thing. Got it? That's combination of those three comes around 36, 38 when they do many times, they find out it. Okay. So that's how. Got it? So this is range maximum thing. Okay. So R maximum possible is what? U square by G. And you put 45 sine, or you can say directly also from this formula, sine to theta maxima is right. What? 1. So theta should be 45, right? 2 theta equal to 90. That is the maximum value, right? That's it. So that's the range maximum U square by G. Okay. For maximum height, what you should do? Throw the particle up, straight up, right? So theta equal to 90. H max will become U square by 2G. First point, write down. Maximum range up to which a particle can be thrown. Maximum range up to which a particle can be thrown is double of maximum height up to which it can be thrown. Maximum range up to which a particle can be thrown is double of maximum height up to which it can be thrown. Bracket, write down. U constant. I will explain what is the meaning. Okay. See here. Here two things are there, range and height he is talking, okay? But here if you see, if what is the relation between R max and H max? R max by 2 is H max, right? But these are two different projectiles, okay? If you solve for theta equal to 45, what will come? H max? U square by 4G will come. For this range, height will come U square by 4G. Okay, there is a different projectile at a theta equal to 90, which H max is coming U square by 2G. Okay, got it? So he is saying, I have a particle. If I want to throw it, I have initial velocity. If I want to throw it a maximum range or maximum height, I can change my angle. Okay, so maximum range, what I will get? Let's say I am getting maximum range 50 meter. Okay. So if I change the angle, I throw it up, then I will get how much? 25 meter. Half. Okay. How much I will get? 25 meter. Got the point? Okay. But in the projectile which I am throwing, when I am getting 50 meter, okay, maximum range, I will get the height 12.5. Okay. Because here, according to this 45-degree angle, range will be, height will be u square sin square theta by 2g, right? So sin square theta will come 1 by 2. It's 45 na, 1 by root 2. U square by 4. So 12.5 will come. Got it? Both are separate. Understood? This projectile and this projectile are different. This have a relation. Got it? That's what we have two factors. Okay? First point noted. Second point. So I am saying here that I have two projectile with the same u at an angle alpha, at an angle beta. Okay, and I am getting the same range. Okay, what will be the relation between alpha and beta? Alpha plus beta equal to 90 degree. How we are saying this thing? That when you equate, you will say sine 2 alpha is equals to sine 2 beta. General equation, general solution of this equation. Okay, what is that? What? Someone said 2 alpha is equals to n pi minus or plus? Plus. Minus? Okay. So by this, what we can say, n equal to 0 if you put. This is coming 2 alpha equal to 2 beta. Okay, that is alpha equal to beta, obviously. If angle is same, then it will come. If you put n equal to 1, what will come? 2 alpha is equals to pi minus 2 beta. Right, from here alpha plus beta is pi by 2. Right? Okay. Got it? So if angles are complementary of each other, right, then it is, their range will be same. That's what I shown you with 30 or that 60, right? So same thing. Okay. So note down this thing. This proof, if you want to note down, it's okay. Otherwise, this is only important. Alpha plus beta equal to pi by 2. Here, write down. Here, draw this diagram first. If range is same for angle alpha and beta, keeping the u same, okay, then alpha plus beta is 90 degree. Particle projected horizontally this side with u speed. Okay, so the particle will go something like this, and we can calculate anything for this projectile. Okay, now what will happen? First of all, that acceleration is in vertical, downward, right? So horizontal velocity same at any point, right? While hitting also same u. Okay, vertically it will slowly increase because downward acceleration is there. Okay, okay, getting the point? So this projectile, if we see, if I talk about same, I am solving in 2 dimensions. So in x direction, in y direction. X direction velocity u, right? Ux is what? U. Ax is what? 0. And uy is what? 0. And ay is what? Minus g. Okay, got it? Then first of all, first thing is what? Time of flight. Okay, so time of flight, how will I solve? For which direction I will solve? Vertical or horizontal? Vertical. First of all, this projectile is combination of two projectiles, two things. Particle dropped from a height, from h height, okay, plus particle this side going with u speed, okay, like that, okay. So in vertical direction, we can say initial velocity 0 and displacement from here to here it is coming in vertical direction. Displacement is how much? Minus h, okay. Particle dropped, you solve na, like that only. So this side, what is the displacement? Minus h, okay. And initial velocity 0 in vertical if you think, okay. And acceleration is minus g. Can we solve for time? Which equation? S equals to ut plus half at square. Displacement minus h, ut 0 plus half acceleration minus g into t square. T came what? Under root 2h by g. Okay. Next is what? Maximum height is this, so h only. Above this he is not going. Below it only. So h is only that. Range. Range is what? Horizontal velocity, that is u, into time is how much? This capital T. Right? Horizontal velocity into time of flight. Got it? Okay. Next thing what he can ask, Vy. While just hitting, about to hit, that point of time, what is the velocity? Vy, first of all. Vy will be how much? Can we answer Vy? Can we answer Vy? Huh? See, vertical direction, final velocity you are asking, right? Just don't listen, try to participate. Final velocity you want. In vertical direction you want, right? In vertical direction, what you know? Here you know between this point and this point, if I apply in vertical direction, initial velocity 0. Final velocity you want, displacement you know, and acceleration you know. Which equation? Third equation, right? So we can say Vy square equals to u square plus 2 acceleration minus g, displacement minus h. With sign you have to put, okay? Let's say gravity you put with sign and h you didn't put with sign, then answer will not come, right? This is imaginary number is coming. That's why you should put with correct variables. Vy is what? Under root 2gh, okay? Now if I ask you, he is hitting here Vy, but tell me, let's say net velocity will be this side, right? What is the angle between with the horizontal? Phi. How much phi? 10 phi. 10 phi is how much? Vy by u. Vy you just calculated. Okay. By that he can answer the 10 alpha also. 10 phi also. Okay. Here he can ask you at any point of time Vy. Okay. What will be that? Velocity at any time t. What is that? Vy is equals to u, that is 0 in a vertical, plus acceleration minus g into t, right? So net velocity will be what? In the horizontal u I cap, in the vertical 0 minus gt j cap. Now obviously this is coming negative only always, right? Downward, right? That's what. Got the point? This is only the projectile, not down. Bouncing question we will do, don't worry. And I will ask, then you will not reply.
What is he asking distance?
Where? Where?
Here of projectile.
What he will ask you?
What if he asks distance travel?
Where distance travel? Means what?
The projectile motion distance travel.
Which distance travel? Continuously bouncing, then Bouncing or what distance?
The path, sir.
Path length. Path length you want to calculate. Path length, mathematics can only calculate. Distance covered he will not answer. He can ask you displacement. So height you know, range you know, so that directly joining both of them. How you calculate if I give you a y equal to x square, like ax square plus bx plus c, can you calculate from x1 to x2 what is that length of the line? If I give you a y equal to ax square plus bx plus c, this is quadratic. Can you solve for the length of that arc for any x1 to x2, any particular value? Can you solve? Same equation here it will come. It's a projectile only. It's a parabola only. We will show this is a parabola. Okay. Got the point?
If you indicate speeds magnitude, sir,
Speeds magnitude.
what we need to deal.
I don't know. You only know. Huh? If friction added, it is bouncing. We will do questions. Don't worry. Even air resistance question also came this year, JEE Advanced. Okay. Like same simple question was there. From here, particle thrown hitting there in the wall, right? But he added the air resistance. That's it. So still there were two methods. Note down this thing. Noted. See, generally air resistance is velocity dependent. Okay. So it's a force B into V, opposite to the velocity. So it will have component, right? So actually your horizontal direction, instead of going with constant velocity, you have a retardation where acceleration is dependent upon the velocity, right? Like we solved na A equals to 4V. Something we solved na like that it is. Like that it was the question this year. This thing noted? Yes or no? Okay, done. Next. This thing note down. Particle thrown this side with u speed at an angle theta with the horizontal. Okay. Then what happens is that this will do a okay. So what we say here is that first of all, component of initial velocity u cos theta and upward component u sin theta. Okay. Horizontal velocity always constant at the topmost point u cos theta only, and here also u cos theta, and here also u cos theta. Okay. In vertical direction, if you talk, u sin theta will first decrease and then increase. Okay, so this is a combination of particle going this side with u cos theta, and vertically particle thrown from a height h upward. It will go up and come down. Got it? Time of flight, maximum height is solved in the vertical, range in horizontal. That's it. Got it? Now, remember at a certain height when we did the projectile, I told you with u speed, if you are doing projectile, here the same u will come, right? At same level, right? Why? Displacement 0. So v square equals to u square plus 2as. Correct? That method same. So here you can see basically you have to use the geometry also a little bit. that here to here, till here, okay, it's a ground to ground projectile like that. Getting the point? Okay, then after this part is extra. Okay, fine. So first of all is time of flight. Okay, so time of flight, how you will solve? Vertical direction, right? Vertical direction between this point and this point. What you know in vertical? Initial velocity, u sin theta. Gravity and displacement. Displacement how much? Minus h, right? So minus h is equals to u sin theta upward, right? So positive, into t plus half minus g into t square. Upward positive, downward negative always. Okay? Got it? From here, this is a quadratic you can solve and get the time of flight. Okay? Second part, maximum height. Okay. For this, we know, you can understand like this, that this is h given already, right? How much is this height? H naught, if we call. H naught is how much? From here to here, you apply equation of motion, right? Initial velocity, u sin theta, final 0. Vertical only you will solve, na? So what will come? U square by 2g. I said na, this to this projectile only, normal. U square by 2g. So h max is actually this h plus h naught, which is u sin theta whole square by 2g. Okay, that's the height max. Range I can say whatever time of flight you will get, horizontal velocity u cos theta into time of flight from here, what you are getting put there. Okay, that's the range. Okay, understood? Next, what? At any point of time, velocity. So at t time, he asks you velocity. I know horizontal, it will be constant. How much constant? U cos theta. Vertical velocity. At any point of time, if I ask you the Vy, between this point and this point, what you know? Initial velocity, gravity, and t time, right? So what is the final velocity? In the horizontal, u cos theta I cap. Vertical, u sin theta initial, u minus gt jk. Okay, that's the velocity at any point of time. Angle also he can ask you, and here you can, as previously I told you, if this quantity is coming negative, that means he is in this region, right? Getting the point? Falling, because this is negative, right? If this is coming positive, means he is in this region. Okay, previously I told this. Horizontally u cos theta into t plus vertically u sin theta t minus half gt. Placement vector is from here, considering this as a starting point. Okay, so let's say this is Vy and it is hitting at an angle phi. So tan phi will be what? Vy by u cos theta. Vy how much while hitting? I can say height h came down, right? So what will get? How you calculate? Initial velocity you know, final velocity you don't know. Initial velocity, height and acceleration you know. Which equation? V square equals to u square plus 2as. So by that what will come? Under root of u sin theta whole square plus 2gh divided by u cos theta. That's how. Okay, that's how you can calculate the angle with it. It will hit the ground. For if it is projected like this with u speed at angle theta from h height. Okay, what are maximum height, range, all thing formula, right? Time of flight. Got the point? Solve in rough. Tomorrow we'll write down. Just leave it. Okay. Next heading will be equation of trajectory. Okay. From h height, particle projected with u speed at a theta angle from down, at the horizontal. Got it?